Good afternoon, everybody. My name is Saoirse, and I'd like to thank you all for joining our Feature of the Month webinar today, where we'll be looking at adaptive testing. In just a moment, I will be passing you over to Rich Shupe, who is one of our business development engineers here at Learnosity. But first, I'm just going to run through some general housekeeping points before we get started. So on joining the webinar, everyone has been automatically put on mute. Time has been allocated for your questions at the end of the webinar, so please ask us any questions using the designated questions section of your GoToWebinar control panel. For any unanswered or follow-up questions that you may have, please feel free to email us at marketing@learnosity.com. And we would also like to invite you to take our feedback survey, which will appear at the end of the webinar. Finally, just a reminder that this webinar is being recorded and will be emailed to everyone who is registered. So again, I'd like to thank you all for joining us today. So it's over to you now, Rich.
Thanks, Saoirse. As Saoirse mentioned, everyone, my name is Rich Shupe. I'm a business development engineer in the New York office at Learnosity. I do pre and post sales support. I've probably spoken to many of you. So today we're going to be talking about delivering assessments based on the ability and responses of the student. Typically, this is termed adaptive assessment, but we have a variety of ways of delivering this kind of exam or test for a student. So we're going to be using a couple of phrases that are more specific to the types of assessment we're going to be delivering. So let's take a look at what we're going to be covering first. We're going to talk about what personalized assessment is. I've basically given you the high level, tailoring an assessment to a student's needs. And then we're going to take a quick run through a bulleted list of the 3 types of assessments that we use, or methods of delivering assessments that we use for this approach. The first is item branching, and this is the type of approach that everyone, all of our Learnosity customers can use. It's a very easy and very customizable, powerful way of delivering dynamic content within an assessment, or delivering content dynamically, I should say. And then we're going to take a look at item adaptive, which is a full-on adaptive approach using the RASH model. And this is where you're going to need to have some psychometricians involved. You're going to need to be evaluating student ability and item difficulty and so on. So it's a higher buy-in, but gives you a lot more power and analytics afterwards. And then we can apply a similar approach to delivering testlets or pre-created assessments rather than delivering one item at a time. And then, of course, as Saoirse mentioned, we'll have a Q&A at the end. So just to get started, like I said before, personalized assessment really allows you to pick and choose the content you're delivering to a student based on their ability. It's not a stock or pre-created assessment. It gives individuality or special care to the student. And you can configure these assessments in a variety of ways depending on the technique you're using. Of course, I'll go over that in the slides. But the idea here is that it's not a standardized test that every single student gets the same way. And it allows you to focus more on what the student's needs are and deliver more complex or more difficult content when they're doing well, and simplify things when they're not doing so well. There are 3 types of assessment approaches that we offer. The first is item branching. Here again, this is something that any developer, Learnosity customer can create. You can set up your assessment using JSON and dictate which item appears one after the other. You can make decisions based on whether they get the answer right or wrong, or what the cumulative score of the assessment is up to that point. We'll, of course, go over all this in detail. And it allows you to make those branching decisions in a JSON definition rather than requiring the higher level of input from psychometricians and so on. Analytics is limited to standard reports. That's one of the benefits of true item adaptive, is you get more detailed or granular analytics based on the student's results. But it does allow you to enter into personalized assessment with a low learning curve and a small investment. And then if you choose to move on, you can, of course, do so. Standard item adaptive, our particular approach uses the RASH model. Not only here, but also when we start talking about item adaptive, we assume because psychometricians are really required to make effective use of this, that anyone who's interested has some core knowledge of this. I also am not particularly versed in the psychometric side of things. So if you have questions that are related to the real nitty-gritty of how we do what we do, I may have to defer them or hook you up with the appropriate engineer that knows more about it than I do, but at least we'll get you started. The RASH model, True Item Adaptive, does in fact give you more granular difficulty levels. You can set the levels and you can set how they're determined. You can configure quite a bit of the algorithm. Based on how the adaptive model works, you must expose the items to a large student population. You need to be able to estimate student ability. You can refine the ability and the difficulty settings through that seeding or that number of times each item is exposed to a student. You can pull the content for the assessment from tags. So you can tag using required tags where any item delivered to the assessment must have that tag. You can exclude items from a pool based on a tag. The algorithm will automatically exclude items that the student has already seen. And you can configure a lot of this as we get further into the presentation. You'll see some of the code examples that will show how that's configured. And of course, the item adaptive obviously ends up with a better calibrated result than the item branching. The item branching is a curated approach at the outset, initializing with a JSON list of items when the assessment is delivered, whereas the item adaptive, learns over time, so to speak. And then finally, there's a testlet adaptive approach, which is very similar to item adaptive, but instead of delivering the item or the assessment one item at a time, the decision making occurs between pre-created assessments. So you might deliver an assessment of 5 questions, followed by an assessment of 10 questions, followed by another assessment of 5 questions. And we'll take a look at some of the demos in these areas as we go. So item branching, again, is that simple entree, that low cost, minimal experience or knowledge required. Essentially, the way a standard assessment is delivered in Learnosity, actually 2 ways. One, an author can pre-create an assessment, as I was mentioning before when I was talking about testlets, where you simply say, I want these items to be included. And another way is for a developer to dynamically build a list of items. So you might say, for example, pull a whole bunch of items with this tag and randomly select from them. You might say, the student has previously seen these particular items, so revisit those as depth of knowledge. You can dynamically generate that list of items any way you wish. This is a similar case where we're going to provide that list of items, but instead of just being a linear array of items, we're going to say, when the student gets it right, go here. When the student gets it wrong, go there. So again, it's a simple way to get started, real easy JSON that you can configure, but it still allows the student to see the next item based on their response. So let's take a quick look at this. The first thing to realize, especially for those of you who are familiar with the way an assessment is initialized, is that all of these adaptive techniques replace the items array with an adaptive object. So instead of just listing the items you intend to use, you provide a set of rules to pick the items that you intend to use. So if you look at this code sample, you'll see that number 1 indicates the entire adaptive object. That's, again, replacing the items array. The type will dictate the kind of adaptive we're using. So in this case, it's item branching. When we look at the heavier or more involved way to deliver adaptive, that's called item adaptive. You'll see that type change. And here in item branching, what we're going to dictate then is a series of steps that the assessment will go through to deliver an item. So, pardon me, in the first case, you'll see a simple item being delivered. The ID of that item in the DOM or in the branching, the reference of that item from the item bank, and an instruction as to which item to show next. So in this first case, you'll see item 1 is the first item delivered, and then regardless of whatever happens, right or wrong or score related, the next item that's shown is item 2. So that gives you an example of setting up an intro item that every single student will see regardless of the response. Then the next item shown having gone down to item 2, will be based on whether the student gets the answer to item 2 correct or incorrect. If the answer is correct, it will jump to item 3. If the answer is incorrect, it will jump to item 4, perhaps a depth of knowledge question on the same topic, or a simpler question in the same area. That, again, is entirely up to you. Excuse me. Then after that, you'll see in the object here, you'll see the definitions for item 3 and item 4. So here's the reference within the item bank for item 3 and the reference for item 4. And in both cases, in the next step, there's a null value. The null value, as we'll see again in a moment, will terminate the assessment. So the path taken then for this student is 1, 2, if correct 3, if incorrect 4, and then based on 3 or 4, end at that point. Let's take a look at some additional information there. So here's an example. Here's an example of going through the branch with a decision-making process. What I just described to you here, without those numbers cluttering up the display here. So you start with 1, go to 2, make your choice on 3 or 4. In this case, if the student got the answer correct, it would terminate at item 3. Now let's take a look at another kind of step, which will give you a decision based on the score, the cumulative score of the assessment to that point. So, actually, sorry, before we go to the scoring example, let's take a look at how we might use this in an effective use case, like a branching tree, a binary tree. So if you look at the numbers as you walk through the JSON, you'll see that as we start with the first item, this is an example where you're immediately beginning with the correct or incorrect. So if the student gets the item 1 correct, they'll go to item 1.1, perhaps further along in that depth of knowledge, but more difficult, in that area of knowledge, but more difficult. If they get item 3 correct, it'll go on to item, step 3, it'll go on to item 1.1.1, and so on, all on down the line. If they start with item 1 and get it incorrect, it'll move on to the item 1.2 branch. And then, of course, here again, you'll see correct will go to 1.2.1, and incorrect will go to 1.2.2. So that gives you the ability to structure a tree as deeply as you need to until you ultimately terminate the assessment with a null value in the next step anywhere along the line. Now that gives us the chance to do things like travel down a tree into a significant depth of knowledge each time the answer is provided, that the answer provided is incorrect. So this is a little bit different. Instead of branching correct, incorrect all the way down the line, we're going to go deeper and deeper into either more difficult or easier or more depth of knowledge, in this case, examples. So in item 1.1, if the answer is incorrect, shows something that explains the topic a little more deeply or a little better. If that's further incorrect, go on to an additional item all the way down the line. At each step, anytime the answer is correct, jump out and go to the next item. So then here again, no decision-making process there. Then in item 3, you'll say if correct, move on, but if incorrect, continue to show additional depth of knowledge items. And of course, you can see the corresponding numbers over here in the JSON. So again, in item 1, if it's correct, go to item 2. If not, go to item 1.1, and so on. This design is entirely up to you. You can configure this JSON any way you wish, of course. So you can follow the B-tree model or the depth of knowledge model, or periodic steps in with other steps that do not require decisions. It's entirely up to you how you structure this. Here's another example of a step that allows you to make a decision based not on the correct or incorrect answer, but on what the cumulative score of the assessment is. So here's an example, if you look at the code, where we have a series of steps, 10 steps at a time, and we go through and say, along the way, each of these steps, this is the definition of decision-making step 1, step 2, step 3. And you'll see here that a decision step can say, if the score is greater than or equal to a specific value, make a decision to go there. If the score is less than a specific value, go to another location in the progress. And because these are decisions only, where no content is associated with the decision, you can refine these in granular steps. So for example, here's a decision-making step that says if the score is less than, greater than or equal to 75%, and here's another example saying is the score greater than or equal to 90%. So for example, if the student gets 90% at the point at which this decision is made, you can terminate early with that null value. If not, go on to the series where step 50 is applied. And I can show you how this looks in a flowchart, talking about the score using it as an example of an early termination or as a way to jump ahead to additional steps or additional subject matter. So if we start off at the beginning of the assessment and go through the first three items, A1, A2, A3, we then come to a decision-making process. So having taken three items, is the cumulative score at that point greater than or equal to 50%? If so, continue to items B1, B2, B11 and B12 and B13. If it's less than or equal to 50%, jump all the way down here to B2, 1, 2, and 3. And again, after going through the first level of B1s, you can say, is the score greater than or equal to 75%? Go to C1. If it's less than or equal to 75%, go down to C2. And it allows you to structure any series of items within those steps or within that configuration so that you can jump to any point in the assessment based on the cumulative score. I just want to stress that cumulative score aspect because what you're testing for at this first stage is the score of the first three items. And as you come down to the second stage, you're testing the cumulative score of all 6 items. You're not testing the score only of this little segment here. So again, if you get down, let's say there were a further test here, you would be testing the cumulative score of 9 items. Okay. So let's take a look at that in action. We're going to show a simple example of one correct or incorrect rather response, and then one based on the score. So if you look at this flow chart, we'll see a first item. If we get this item correct, we'll see a second item, item 3. And if we get this correct, at this point we'll test the score. And if we get this correct, we'll jump to a last item. If not, we'll see an interim item. So again, this particular first item is a French translation, or identify the French word by picture. So if we get it wrong, we'll see another example of identifying the French word that was spoken. If we are correct on the first item, we'll jump straight to a text example. So I'll take this twice to show you that use.
Un chien. Une maison.
These audio files are playing, just pronouncing words.
Un livre.
So I believe it was dog, house, coffee, and book, if my memory serves. I spoke over them. Okay, so I got those right, and I've skipped the second audio portion, and I've gone straight to the first pull-down example. So I'll choose some items here, and I think I'm going to get this correct as well. So I'll jump to our third item, and then I'm going to arrange these numbers in size order. And if I get this correct, I should end the test. So let's see. There we go. I think that's correct. And then we end. So now I'm going to retake, and I'm going to make those 2 mistakes to show that the branching will give you a further item in that area. So again, I'm going to get the answers incorrect on the French pronunciations and end up with a second example. Then I'm going to get some incorrect answers there and get 2 questions following that decision.
Un chien.
So let's say
maison.
Cat, car,
le café,
house,
un livre,
and coffee. That's incorrect. So now we're presented with a follow-up question.
Le lapin,
So let's say cat.
l'oiseau, le pigeon,
So we
le
get
chat,
2 wrong. So now we come to our text. let's get this wrong as well. And we should see now 2 items that follow. Here's our additional item here. So as you can see, the branching, which I'll review one more time, gives you the ability to offer these follow-up questions. This is the second audio pronunciation. Here's your 2 items that follow your score because it was too low to terminate early. If you had a good score, it gave you only 1 follow-up item and then ended. So the ability here is to, again, structure your steps based on decision-making, based on scores. Here's my final example, which will show you an early termination approach, where it'll simply be a linear exam all the way through. But then at this point, you can say, does the student know this material so well that at this point they have a 90% correct answer? If so, end with a null value and you terminate early at item 10. If not, continue on all the way through the rest of the exam. So this gives you a lot of freedom. It gives you the ability to curate this from an author's perspective. You can build this in a simple way with a small investment. Obviously, you need some awareness of your content and how your students are doing to plan, but you don't need a full staff of psychometricians on hand to estimate the item difficulty and student ability. That's where we now come into item adaptive. This is the term for our true adaptive or RASH model offering. And this is a fairly complex process, so I thought I'd explain how we engineer each of these component parts for the process. And the first part is authoring the content. So once you have an item, for example, you need to assign a difficulty level to that item. And you can do so through existing data, or you can seed those items into a test group and continue to refine the results based on how they're perceived by that particular test group. So here's an example of a difficulty level of -3.77 being applied to this item. This is an easier item. Typically, the values start at 0 and have a plus or minus tolerance with the range of ease to difficulty that you want to apply. So this is a very easy item, -3.7, closest to, for example, -4 as one lower tolerance. And then higher items of greater difficulty would be a greater number. And we'll see that as we go on. Next, we're going to figure out a way to estimate the student's ability. So you typically start with an initial ability and then estimate that ability through testing. The primary way that our model, the RASH model, estimates the student ability is using the maximum likelihood estimation method, and that's a behind-the-scenes process that continues to refine. But in order for that to work, it must have a mixed response pattern. There must be at least one correct and at least one incorrect response. So prior to that, you can use the expected a posteriori example, which will allow you to define a mean expectation, a standard deviation, the upper and lower bounds rather of the difficulty levels, and the number of points assigned. And that will allow the algorithm to start that estimation prior to having a mixed response pattern. Once that mixed response pattern is established, the algorithm will then switch over to the MLE method to continue further estimations. So as we're going through, we're continuing to refine the student's ability. In each case, we're presenting the next item in the process and in the assessment, and in doing so, we're invoking an algorithm to make that choice. And it's a tiered or precedence setting, using precedents to determine that. The first thing is we want to be able to pull a list of available items that the algorithm can pick from. And to do so, you can set up a list of required tags. So the first thing we're going to do is pull from the item bank a large group of items that have a particular tag, and only those items with that tag will be delivered in the assessment. In this case, you can see here, we're just because of the screenshot there, we're using adaptive life cycle operational. So only tags with that item. This is just a screenshot of the authoring environment, not the code. You'll see that that's the only tag we're insisting on. This particular item just happens to also have another author tag. So tags or items that have the adaptive lifecycle operational tag will in fact be eligible for choice in this eligible for selection in this assessment. We can also exclude items either explicitly by listing the item references or by providing a group of tags where if that item has that tag, it must be excluded. I'll show you all of this as it appears in the code as well. Then the item selection algorithm will avoid picking an item that's already been seen in the current session. We don't persist that data across sessions, but within that session, we don't want to show the same item twice. So we'll make sure that if that happens to be selected through the ultimate random selection, that it will be discarded and another selection made. Then we're going to take a look at the ability estimate for the user up to that point. And we're going to use that to figure out the target difficulty of the upcoming item. If you've defined a difficulty offset, we're going to apply that to the target difficulty so that you can hone in easier or more difficult. Once you do that, once that offset has been applied, there's a range of difficulty. So that tolerance is defined in the algorithm so that only items with a difficulty that fall within that range can be selected. And then once that's all been determined, any item that satisfy all of those criteria, a random selection is made. So again, this is a level of depth that perhaps not everyone will need if you're not interested in pursuing full item adaptive, but just by giving you a big picture, rather than getting into the heavy psychometric stuff, ideally you could determine whether you want to pursue this in the future. Then what we have thus far is a selection criteria that continues to deliver items. So we need some way to terminate the assessment. And there are essentially two ways to terminate. One is when a fixed number of items has been seen, and the other is when the tolerance threshold of student ability estimate has been reached within that threshold. When the error of estimating the ability is below a certain level, you feel you've fully honed in on what the student is capable of doing at that point, you can terminate the assessment. So by order of precedence, we'll start with a minimum number of items. We must, in this case, show 5 items. If 5 items are shown, we then have a second criteria that says, well, assuming that they're all over the place and nothing is working as expected, we're going to terminate after the student has seen 50 items. But all along the way, if our random selection of items with the appropriate difficulty levels are accurate and it's continuing to hone in on the student's ability, once that margin of error falls below, in this case, 0.7, that assessment can terminate prior to seeing 50 items. So that gives you the ability to determine how long the assessment will run within these criteria, and you can change that for each assessment that you configure. So here's a quick look at all of that code collected. Give you a quick summary or rundown on that information. So outside the highlighted area is standard housekeeping. This is the particular user that's taking this exam, a unique session ID, activity ID for analytics so that we can show reports later on, the name of that activity for similar reasons. We're going to be rendering this in our UI, our assess UI, and we're seeing this for the first time. And then, of course, down here at the bottom, just as a bookend, we have another housekeeping thing, which provides the title for the assessment. So now within the highlighted area, this is the adaptive object we talked about before. We used to see item branching. We now see item adaptive as the type. We are starting off with an initial ability for the student, again, right there in the middle of the result of 0, an item difficulty tolerance of 0.1, an offset of 0. We're not changing that difficulty for a particular student taking this assessment, that expectation rather. We then are setting up our expected a posteriori evaluation prior to ultimately having a mixed response. So here we're going to start with a mean of 0. Standard deviation will be 1. The minimum difficulty will be -4. The maximum will be 4. And the number of points will be set for 50. Then we have a termination criteria set up for, as we showed you just a moment ago, a minimum of 5 items, a maximum of 50 items, and then an error threshold of 0.7 for potential early termination. And then finally, for item selection, we have a required tag set of adaptive lifecycle operational, a blacklist tag set that says anything with a tag unit 2.7 conditional statement should be excluded from this particular assessment, and then a manual exclusion of item A and item B, so that no matter what happens in our selection algorithm, you want to exclude those items full stop. So having set all that up that way, the student will go through the process and continue to be delivered items based on the difficulty level in the item selection algorithm, and we can demonstrate that for you now. Actually, yeah, one thing I want to show you before that is that when you're developing the assessment, you can run simulations within the author portal that will give you a chance of looking at the results. So here's a particular assessment. You can see that there are 50 or so items, or actually, sorry, let's see. Yeah, maximum of 50 items chosen with these particular tags. In this case, there's adaptive lifecycle like I showed you before, but also I've set up a pool for this particular webinar. And then if you take a look at the adaptive tag here, you can run a simulation. Let's show you what that looks like first. You can set a simulation for 1 user, 500 users, 1,000 or 10,000. That'll take some time, so we won't do this live. Perhaps we'll do 1 in a moment. You can give that simulation a name, of course. And then you could choose standard deviation, bimodal, or a custom distribution. Standard distribution, bimodal or custom distribution with a standard deviation of 1 and a mean of 0, which is fairly typical. And we'll take a look at one that was run for 500 students. And you can see the values that you set for that particular test, that simulation. You can see the definition, the JSON that we just looked at earlier. And you can see how the item exposure was fared in this particular assessment, how the items were delivered. And you'll see the difficulty level down at the bottom, the number of times the items were exposed. So you can see a fairly standard bell curve here in that standard distribution option that we chose. You can switch over to a fine-grained distribution model or visibility so that you can see all of the individual ranges of difficulty levels that were delivered within the ability to show here in width. And then you can follow through and see each of those item difficulty levels as you go. And in this particular case, an item difficulty level of 0.1 was shown 1,080 times. And then, of course, as you go down to our outliers, you can see the values are far less, showing that standard deviation. So that's just one simple example of what a simulation might look like. And it's real handy to be able to do this for only one student. Hopefully this will progress quickly, leaving time for some Q&A, because you can do, even though it's not particularly wide-reaching data, the breadth of the data is not significant, you can see through one student if everything is working as expected. Then you can run a 500 or 1,000 or 10,000 student simulation to make sure that your expected results are in line with that first test. So that little simulation is a real handy thing to get you started, and then we can show you what the student will experience through an item adaptive example. And we're doing this by showing you both the correct answer and the difficulty level. So here's the first item presented. The difficulty level is 0.04. And you'll see as I continue to answer the questions correctly, the difficulty level will adjust based on that selection algorithm. It continues to get larger, giving harder and harder questions as we go. Obviously, obviously that will reverse itself if you started getting questions incorrect. And as you hone in on the student ability, that error threshold will ultimately be reached, or perhaps if the user is jumping around, they may reach 50 items in this case before that and terminate based on that result. But as you can see, the difficulty level continues to climb, and of course you can see that reverse as well. And therefore each of those items are being delivered based on the student response. Hopefully that's clear, a little meandering there perhaps, but that gives you a big picture idea of how item adaptive works. Now let's take that same idea of how things are selected and apply it not to a single item, but to a testlet of items. So if you look at this example, each one of these testlets is a pre-created activity. They might have 3, 5, 10, 20 questions. It's rather than a single item at a time. You have the start off with a single testlet. If they, the testlet selection algorithm based on the ability and difficulty level assigned to the testlet might select this testlet. The student might go through those 5 or 6 questions. It might then select this testlet and then conclude. So we can show you that where the decision-making process is at the testlet level. So here is an assessment that begins with 3 questions. So we'll take all 3 of these questions. I won't bother answering them for speed, for brevity. And then at the end of this first assessment, that algorithm chooses testlet number 2. In this case, there are further 3 questions. And then another decision is made for a test of a further 3 questions. So rather than making those decisions on a per item basis, it's making decisions on a testlet basis. This is less common, but it's an option that allows the authors to become more involved, where rather than putting together an assessment of 50 randomly selected items, the author may curate and say, having arrived at this assessment, I want to make sure that these 3 items are included. Then we'll choose the next assessment where I want to make sure those 5 items for that particular topic are included, and so on. So that's a quick overview of our various options. I want to now open this up to questions, and I'll warn you once again that I am not a psychometrician. I hope that I won't have to, but I may need to defer some of the more technically advanced questions about the RASH model or other things that may come up that I'm not as well versed in, but certainly open the floor to questions. Saoirse, are you fielding questions? I see nothing in the chat. There may be no question.
Don't think we have any for the moment anyway, unless anyone's frantically typing. But perhaps that's the nature of the whole adaptive thing, that maybe they are slightly too technical to answer over today.
The idea here was basically to give a big picture overview. And again, as I mentioned at the top of the webinar, based on your particular experience or your particular decision to join, you may have just wanted a quick exposure of what was possible. And if you do have particular technical questions, I'll try to field them.
There's just a couple coming in here now, Rich. I don't know if you can see those or not, but I can call them out to you if you'd like.
Yeah, I don't see anything coming into my chat window. Oh, sorry, questions. I didn't notice that was available. Here we go. Is it possible to have an item branch set of sample items, then go to a testlet or item adaptive? That's a great question. The item branching process is defined by the JSON and is limited to items. So when you pursue item branching, you're looking at an item branching decision based on each individual item, item by item. It is possible, however, to build it to replicate that experience. For example, because you can choose when and where to put the decisions into item branching, and perhaps I can show this point. Let's see. If I switch back to the item branching JSON, or let's go to one of these. Let's talk about our scoring here. This is an example where the first decision was made at item 9. Now, regardless of whether this is correct or incorrect or based on score, that's not the point. The idea is that you can say, go from the first item to the second item to the third item with no decisions. So if you think of, let's say, each line of this flowchart as a testlet, you could say, show the first 3 questions, then make a decision. If that is cumulative score, or if the last question, the assessment is correct, whatever way you want to decide it, jump down to the next 3 or the following 3. So although you can't jump from item branch to item adaptive to testlet adaptive, you could simulate testlet adaptive by simply sequencing the items the same way they would appear in their individual testlet. And you can't combine item adaptive with branching regardless of testlet. So I hope that answers the question. You can simulate it, but you can't do it directly. We are in awe. Well, I certainly appreciate that. I'm a good presenter, I realize, but really the credit goes to the engineers who are developing all of this stuff and Learnosity as a company. So I demur. Is everything set up via API rather than interface? That's another great question. Item branching is entirely set up with JSON, yes. The testlet adaptive is set up with partially set up with the activity builder. However, the decision-making process to configure the rash model is also set up in JSON. So the author will have, or the UI-based approach will have some involvement, but ultimately the initialization process is all done through JSON by a developer. Not a question, just a thank you. Great overview. I appreciate that. Kidding aside, it took me some time last night to really refresh my memory on some of the item adaptive aspects of this that I'm not familiar with. It's certainly over my head. And the team in Sydney have done an amazing job presenting some of these options to you, and I'm glad that you see the power, and I hope that you'll be able to use it. If there are any other questions, let me know. Otherwise, I'll turn it over to you, Saoirse.
Yeah, thank you very much, Rich. And yeah, I hope you all found today's session useful. As Rich said, for any follow-up questions, feel free to contact us. You can email us at marketing@learnosity.com, and we would also like you to take part in our feedback survey if you have time, which will be displayed in just a moment. So that's all for today. I don't think there's just another thank you coming in there from Wendy, so thank you, Wendy, but that's all from today. So thanks to Rich, and we hope that you will see you for the next Feature of the Month webinar. Enjoy the rest of your day.
Agreed. Thank you very much, everyone. I hope that my blathering made some sense, and if you have any questions, please follow up with your support rep or with Saoirse or whoever that you may need to contact. Thanks again for joining us.